Good afternoon, everybody. Thanks for attending today's webinar. My name's Peter Nobes. I work with Applied Cytometry. And what we'll be doing today is to look through how we can do high dimension analysis with VenturiOne and some of our associated products. If you have any questions at any time, please feel free to type them in the chat. We will have time for questions at the end. So if you have any questions, please feel free to type those in the chat. I'd also like to introduce you to Erin Irons and Joe Crofts, who are from Applied Cytometry also. So you can feel free to direct any questions to them in the chat. And if I could ask them to collate any questions, if I miss any of the questions that are asked, please give me a kick later on. So today what we're going to be doing is looking at how VenturiOne and its associated products can help you look at high dimensional data. VenturiOne is our state-of-the-art flow cytometry FCS data file analysis software that was designed from the ground up for speed and simplicity of use. It's designed to work under Windows 32 or Windows 64-bit. It will also run on a Mac OS system. We use high-speed parallel processing of the PCs to maximize the speed at which files can be processed. And we use a Microsoft-style interface to give you a familiar-looking program. VenturiOne has all the key features that you'd expect to see from a standard flow cytometry analysis software, and we'll be looking at that in action later on. Also today, we'll be looking at CytoSwarm. CytoSwarm software is our PC program that allows you to send flow cytometry data into the cloud, where we have a program called Myriad. This is an algorithm engine that sits in the cloud and will process your data and will perform R-based algorithms without you having to have R on your local system. So CytoSwarm allows you to select files and configure the algorithms that you want to run. You can perform a series of algorithms, so you don't have to do just one algorithm at a time. You can sequentially process data through multiple algorithms. We send data from the local PC up into the cloud. Up in the cloud, it's processed. We can then download data file and then analyze that output file in VenturiOne. The idea is, using this system, that you can use the dimension reduction algorithms without having to learn R or Python or any other programming language. By performing these things in the cloud, it means that we free up your local PC, and you can be doing other things on your PC rather than using that to process algorithms. So let's start by looking at CytoSwarm. CytoSwarm is a very simple application that when you start it up, you can see a series of jobs. These are jobs that I've already created where I've uploaded files to do a specific task or tasks. We can add files and pick any FCS files to process in the cloud. So I can choose any number of files that I want to. I'll keep it simple just by doing a couple of T-cell files in this case. We can give a job a name. And then we can choose what algorithms we want to perform and in what order. So currently in the version that's released at the moment, we have flow cut, which is an algorithm to sort out any outlying data. Flow sum, we have a merge algorithm, we have an associated split algorithm, we use t-SNE, the standard t-SNE multicore, the t-SNE extended multicore, and UMAP algorithms. All of these are standard R algorithms, and you can pick which algorithm you want to run or which series of algorithms you want to run, and then process those files through that algorithm. So the order that I might want to do things, I might want to merge files. If you're running large files and you just want to look at individual files, you don't have to merge files if you don't want to. If you're looking at a series of files that are all related, you probably do want to merge those files before you upload those into CytoSwarm. So in this case, I've got a couple of files that I want to look at. I'm going to merge the files together. So I choose the algorithm that I want first. So I've chosen to merge, and I'll add that to the list. I can then tell the system after merging, I want to do a flow sum algorithm, and I add that to the list. I can choose to do t-SNE, add that to the list. And then I can choose UMAP if I want to, and add that to the list as well. So what we're going to do is we're going to take the files that I've selected, we're going to merge the files together, perform a flow sum algorithm, then perform the t-SNE algorithm, and then perform the UMAP algorithm. At the end of this process, we'll be able to download a file which has all of these functions added to them. Selecting Next allows me to choose which parameters in the file I want to process. So I can take out any parameters that aren't actually stained or that I don't want to use as part of the algorithm. And then I can go through the properties of each algorithm. So the first step, if you remember, the first algorithm I was going to perform is a merge algorithm. Here I can choose the total number of events. I can also set the name of the output file. I can press Next to move on to the properties of the second algorithm, which was the flow sum. And here we have all of the standard properties of the flow sum algorithm that you can adjust, together with a link which shows you the algorithm source and the GitHub source where the algorithm was obtained from, and where more details of the algorithm and a user, any user documentation is also placed in that GitHub reference. And that is from the publishers of the algorithm. So that's the link for flow sum. Then we have t-SNE with the properties for the t-SNE. And UMAP. Finally, we have a summary of all the steps that are going to be performed and the algorithms and the settings that are used. You can save this method for using at a later date. So that means if you're going to do the same thing again, you don't have to remember what settings to use. You just say, I want to save that method for later. And when you load the files, you can load that method as well. Once you've completed that setting, press finish, and the system will now upload the files into CytoSwarm and will start processing those files. At this point, all of the processing is taking place up in the cloud. You can close this application and come back at a later time once that processing is completed, and then download the file from CytoSwarm to your local PC. At any point, I can double click on a job that is in process, and it will show you where in that process the system is. At the moment, it's just initializing the process. So at the moment, there's no details given. As you start to complete each step, so if I look at a previous job that's been done, you can see here at the end of each step, I can see what's been done, and I can see a preview of the output. You can also have multiple jobs going at once. So here I've loaded a T-cell panel. If I want to, I can now put a second job into process. If you've got a method in place, then this is where you could open your method and say, let's use the same method that I used for the T-cell panel. So this now will perform the merge, the flow sum, the TISNI, and the UMAP that we performed on the T-cell panel a minute ago. Select next, choose what parameters I want to perform the algorithms on, and then I can press finish, and it will upload those files and begin processing that job. The amount of time that it takes to process a job will depend on the number of files you've uploaded and the size of the files, and whether you've chosen to merge the files or not. Once processing is complete for a job, you can then choose whether you want to download the results for all of the steps or download just a results file. So here I have a sample as completed. So we have an output file from each step. So what you can do is you can choose to download all of the intermediate files, or just the output file that is the final output file that contains all of the algorithms included. So if I just create a new folder here. So here, if I choose this file, I can download all steps. And that will download copies of my original files, and then the output file from each intermediate step. The final file from the final step, the final FCS file, will contain the file that has all of the added parameters in. If you choose to download results only, it will only download the final file that was the file that has all of the steps included in it. Once you've downloaded those files, you can then use your favorite flow cytometry software to analyze that data. So this is VenturiOne software. With VenturiOne software, if you've not seen it before, the software has essentially 3 areas to look at. We have a playlist, which will show which files it is that we're analyzing. We have a workspace area where we can switch between plots, results, overlays, and reports. And in the latest versions of VenturiOne, we now have our cluster tree display that allows us to look at the FlowSum algorithm within a cluster tree view. To load files in, here I've downloaded a file. I've loaded our T-cell panel, so I can take a file and just drag that file into VenturiOne, and that will display the file name. By default, it will show you the forward scatter and side scatter plot, and it will also show you a preview of a thumbnail of all the other parameters within a file. And that includes, if you look at the end of the file, so here we have our added parameters. So the thumbnail here, you see our standard parameters, and then at the end we have our FlowSum, our t-SNE, and our UMAP parameters. You can choose what parameters are displayed in that thumbnail view by just checking or unchecking parameters. One of the parameters that's displayed is the file scattered. That parameter will be displayed if you've chosen to merge your data within CytoSwarm. And that file, that parameter, shows you the different files. So the first peak is events from file 1 and the second peak from file 2. So I can now start to use VenturiOne to create an analysis. So here, this thumbnail allows me to just double click on a particular plot that I'm interested in, and that will add those plots. As I double click them, it will add those plots into the analysis area, and this analysis area is where you're going to analyze your samples. So I can create a region around lymphocytes or my mononuclear cells. This has got probably monocytes in there as well. When I click on a region, the previews are now gated on that view as well. So rather than having to create a plot and then gate it, create a plot and then gate it, create a plot and then gate it, I can create a region, click on that region, and now get a thumbnail view of all of the plots, and these plots are now gated on that particular region. And I can now add as many plots that I want to look at in greater detail as I want, just by double clicking on that particular plot. So here now we see our t-SNE and our UMAP parameters. If you've created a FlowSum algorithm in your processing, then the Discovery tab allows you to choose what parameter it is that you want to analyze. In this case, we've got FlowSum, and that will now add a minimum spanning tree view into the workspace. What we can do within VenturiOne is now look at data, comparing the data between standard plots, the data dimensionally reduced plots, and the cluster tree plot. So we could, for example, track populations on all of these different kinds of plots. We can put regions on the dimensional reduced plots, the TISNI and the UMAP, and trace populations across the standard flow cytometry plots, across the previews, and across the cluster tree plot. And the easiest way of doing that is by using color. And to see color plots, what I can do is I can choose to display, change the format from a standard density plot to a color precedence plot. So now you'll see here are my mononuclear cells. If I move the gate up onto the granular sites, then you can see where they are located on the standard plots. If I want to gate plots on region A, so I'm just looking at the mononuclear cells, I simply select the plots that I want to gate on a particular region and select the region I want to gate on. For the discovery plot, for the tree plot, we can use the gate by to again gate that plot on the mononuclear cells. We're using color precedence, so I can choose within precedence order what colors I want to display. As I add new gates, I can choose whether or not I want to display that color on plots. For the moment, I'm probably not interested in the red. Let's look at some different populations. So here, if I do something quite simple and just say, okay, let's have a look at our CD2, CD4 cells. I can pick a region, and if I want to change that particular region color, given a brighter color, I can do so. That color, that population, you can see is now shows where the color now shows where that population is displayed on our TISNI and our UMAP plots. We could also show that color on the previews. I can choose what our previews are gated on. So here we can see where those CD4 events are on all of our thumbnails within the preview. And in the cluster tree, I can choose to backgate from a standard plot onto the cluster tree plot. So if I choose to backgate and then pick that same region B, that will then show you where that particular population lies. And as I move that region around, that region will show where your various populations are on the cluster tree. And also on the previews. I can, of course, go from the standard plots from the dimensionally reduced plots and ask to see where those particular populations are. So if you're hunting populations either from a standard plot or from the new style plots, you can see and identify data across the different types of plot. Now here we had our two files. So what we can also do is say, okay, let's have a look at that plot, for example, on our two different files and see if there's any difference. So what I can do is I can say, let's gate that plot on the mononuclear cells, and then I can ask for this plot to be gated on our first sample, D, and then I can duplicate that plot and ask it to be gated on E. So we can now use these two plots to see if there's any difference between our two samples. So I think you can see using these techniques, you can quite clearly see differences between different samples. You can compare the standard plots to the new style plots to look at t-SNE versus UMAP and look at populations on the FlowSum algorithm as well. So on the FlowSum algorithm, on the FlowSum tree, what we can do is we can create cluster groups. Try again. Just reduce the number of colors I'm showing for the moment. So here on the FlowSum cluster tree, we have a number of clusters that have been detected. And what we can do is we can create a cluster group that effectively allows us to choose which of these groups we want to put into a population. And we can ask for a cluster group. We can pick a particular color for that cluster group, and you can add individual clusters into the cluster group. And you can see and track where that cluster group is, again, across all plots. From the standard plots, the dimensionally reduced plots, and on the previews as well. So this helps you identify what particular populations you're looking at. So here I've identified some clusters that are a similar group. As you go, and if you select something that's a completely different group, then you can see that highlights that, okay, this is a different population. I'll want to put those into a different group. So here, this particular cluster is a CD2 negative, sorry, CD2 positive, CD4 negative population. And I can rename that cluster group accordingly. If I create a new cluster group, I can select a new population. And here, this is our population that's negative on, looks like negative on all. Once you've done your analysis, if you save your analysis, you can save everything that you do in the form of a playlist for later use. And if you then open up a playlist at a later date. So this is an example of an analysis that I did earlier on. And here what I've done is just simply compared two populations. This is just the CD4 and CD8 population. You can see how that compares on the cluster tree, where our CD4s are red and the CD8's blue. And those same populations can be tracked across the Tisney and UMAP plots and onto the standard plots as well, and onto the previews. So using CytoSwarm and VenturiOne gives you a very powerful way of looking at dimensionally reduced data in a very simple way. Are there any questions that anybody has?
We haven't had any written in the chat yet either.
Pete, is there a limit to the number of files that you can merge together?
No, the files, the size of the files really is what limits the merging. I think it's about 9 million events. I think it's limited to, Mark.
Thank you.
Typically, people will either merge together lots of files from some samples, or it may be that you just want to process individual files. And you can, using CytoSwarm, you can process either way, merged or unmerged.
And what was the kind of size of these data files that you were using?
So these particular files were about 500,000 events.
And you've not downsampled them in any way?
Not downsampled them in any way at all. I have an example playlist from the OMIP 42 data. So looking at some very high number data. These are like 3 million event files each. So here what we've done is merge two files, one of which is, as you see, about 1.5 million events. and the other about 1 million events. So it allows you to process that number of files. You do have to play around with some of the settings of Tisney, particularly when you start to look at large data number. We find that UMAP tends to be much more reliable when looking at very high numbers of events. So in this particular example, this is one of the OMIP 42 events from a Cytec machine with all of these colors, plus the added parameters that we've added in. Any other questions from anybody else? Please feel free to unmute yourself and ask the question. Okay, in that case, I'll say thank you, everybody.